My name is EDGARS JANSONS. I'm from IPRO. And today we talk about how we build the cloud. My main job, I do the design of infrastructure and deployment. And some years ago, they were very difficult to build design. It was very difficult to build design who has good flexibility, yes, efficiency, easy to manage, and it was easy to use. But now, when we have three vendor alliance with Cisco, NetApp, and VMware, we can build very flexible design. And today we will show you how it's made. Yes, my colleague from Cisco, Tommy, helped me, and IPRO team as well. Yes. Okay.
I'm going to take care of the easy part. I'll just do the talking while they do all the work. So it's a good division of work.
Okay. Let's start.
We are 2 minutes in, and it seems that the cloud is halfway there. The first thing to go in was a NetApp file, fast system, and that seemed to slide in quite smoothly. The second bigger box here was the Cisco Unified Computing System blade enclosure, or the chassis. So that's now in. On top of that, we have a couple of fabric interconnect switches. I will probably explain what they do in a little while, as we can then see this thing take form and some cables being put in. And now it seems that the guys are installing Cisco Nexus switches, which are Cisco's data center switching platforms, able of running Ethernet and fiber channel on the same ports. So, it is up to this SFP module what the port is actually running, whether it is Ethernet or fiber channel. And at the very top, the box here is the Cisco Catalyst switch, which is just plain old Ethernet switch that is used for management networking purposes here. In a typical FlexPod setup where you have NetApp, Cisco, and VMware, this would be your old network where you have your old LAN and SAN connectivity. So now let's see where we are. We have the power cables plugged into most of the equipment. I guess the power is off because it's still very silent. It will be very noisy when they actually put the power on. And now, as you can see, EDGARS is putting in these green cables. They are the management color. That's my trousers. That actually creates a management cluster connection between these two systems. So these two fabric interconnect switches are connected to each other with direct 1 gigabit Ethernet cables, those short green cables, and as you can see, it is copper, and that is actually what limits how far apart you can put these two switches. They need to have a physical link between them. That's how they make sure that they know who is taking care of the management in the cluster. Let's see, we had more Ethernet put in, and that seems like a management connection. So it is a management cable that will be then used for getting IP access to the whole system. Yes, EDGARS is now plugging in the management cable. I'll just see what's happening on the back side just to make sure that everything is in order there. The back side is clean. We have a couple of servers plugged into the blade enclosure. We have the NetApp file there sitting nicely, and everything is in order. Let's see, I'm getting tangled here. If you can see from the video, this is the blade enclosure, and we have 6 empty slots at the bottom here, and here at the top we have 2 servers that will be then forming our computing part of the cloud. As you can see, you can altogether put in 8 servers here, and well, I'm not going to start screwing them, it might mess up the whole system. Let's come and see what's going on the cabling side again. Well, this is getting interesting. There's now more management connections being plugged in, again marked by the green color. Everything that goes into this switch at the top is a management connection. Just Ethernet IP on top of that, and that is used for only to get connectivity to these devices. Well, now EDGARS is plugging in a TwinX cable. It is actually a copper cable, so shielded copper, and it has the SFP modules attached to the cable directly. So as you can see, you cannot remove the cable from the SFP module, and that's why we can build very cost-efficient connectivity, 10 gigabit Ethernet connectivity. In a traditional setup, you would have a module such as this, a separate SFP module, which provides the optics, and then you would have a fiber connection between 2 of those optics modules. So all in all, you would need to have 2 optics modules and 1 fiber cable. Now, by using these TwinX cables that are copper cables with the SFP modules directly attached to them, we can actually get the same 10 gigabit Ethernet connectivity with just a small fraction of the cost. A typical SFP module will cost several hundreds of euros, but a TwinX cable like this is just tens of euros. So it's a very cheap option to get 10 gigabit Ethernet connectivity. Now, what is happening? EDGARS has now plugged in the blade enclosure from the fabric extender modules, which are the I/O modules in the blade system, to the fabric interconnect switches. So these boxes take care of all of the I/O, they take care of the traffic, they do all of the switching, and they are connected to the fabric extenders in the blade enclosures. So these are the I/O modules. And because the name is fabric extender, it means that it is not an individual switch, it is an extension of this switch in top. So as soon as the cable is plugged in, this module here becomes logically a part of the switch that it is connected to. Then there are other cables now going from these fabric interconnect switches to the Nexus 5000 switches on top. The Nexus 5000 series switches are, they are Ethernet networking switches, so you can run 1 gigabit or 10 gigabit Ethernet, as we are actually doing here, and you can also run fiber channel, native fiber channel on all those ports. Now, by connecting the fabric extenders to the fabric interconnect switches with TwinX cable, we are enabling fiber channel over Ethernet. And now there's a connection from the fabric interconnect switch to the Nexus switch, which actually extends that fiber channel over Ethernet connection all the way to this box. What happens with the fiber channel we will soon find out as we get more cables plugged in. Now it seems that the blade enclosure itself is fine. It has altogether 1, 2, 3, 4 10 gigabit Ethernet connections. So it should be enough for our 2 blades. 40 gigabits of bandwidth for the 2 blades, going into 2 separate fabric interconnect switches. Now what is interesting with these cables is that not only do they carry all IP traffic and Ethernet traffic, they also carry all management traffic. So, as I mentioned, the I/O modules in the blade enclosure are logically part of these fabric interconnect switches. Well, actually, the whole enclosure, the whole chassis is logically now part of these switches. So all of the management you have to do in the system, from the hardware perspective, you do through these 2 boxes here. They form a management cluster by those green cables, and then they take care of all the hardware management in the blades here down below. Now it seems that we are making connections between the 2 Nexus 5000 switches. The reason for that is that the switch that belongs to the server system, the fabric interconnect switch down below, as you see, there are no cables going between these 2 boxes, except for the management cables. So from a networking perspective, both from the fiber channel and from the Ethernet perspective, they are separate. They form 2 separate fabrics. And now if we want to connect these fabrics, we have to do it up here. So this is where we are now connecting the Ethernet through those cables. Now I mentioned that the fiber channel traffic from blades is coming in through these twin-X cables to the fabric interconnects and there up to the Nexus switches. And now EDGARS is plugging in traditional native fiber channel optics, SFP modules there, and then cables, fiber cables that are now carrying pure traditional native fiber channel traffic. As you can see on the fabric interconnect modules, he's plugging the cables, the fibers, into ports that are marked with a green color. So this means that these green ports, they are only fiber channel, native fiber channel only, whereas the rest is Ethernet, capable of running fiber channel over Ethernet. On the top here, in the Nexus switch, you notice that there is no green color, rather everything is orange. And that orange color actually specifies that all the ports in that box are what are called unified ports. So the choice of the optics module, the SFP module, actually defines what protocol the port will be running. If we put in an Ethernet module, it will be running Ethernet. And now as we have fiber channel optics in, it will be running native fiber channel. And now there are fiber channel cables going from the switch at the top to the NetApp filer down below. So this is how we actually get fiber channel connectivity all the way from the blades through the twin-X cables to the Nexus 5000 switches, and from there with native fiber channel to the NetApp filer down there. Now I have to admit I haven't been paying attention well enough so to notice that whether the NetApp filer already has NFS connections.
Yes.
It has.
Yeah,
so they are
connected here.
Yes, very good. So there are Ethernet cables going from the NetApp filer to the Nexus switches to carry Ethernet traffic. So we have both fiber channel and Ethernet connected to be able to run both IP-based storage traffic on Ethernet, so NFS, and fiber channel-based storage traffic on FC. So how does it look? Everything ready?
Everything is ready.
Okay. The cloud is up except for the power. We don't have the power. We don't have the software.
Okay, yes. But the system is pre-installed, yes, and now we put the power on, yes, and I'll show you the cloud components, yes. Most of all, Toby, yes, will talk about the system, yes, but I'll show you the real components, yeah, for the software.
Yes, very good.
Any question?
Stand up.
This is the power component. Here, yes, at the bottom of the map, yeah, there is also management. That's multi-store functionality. We can see physical box with three files, yes, and manifest as guided files from the support, yes, multi-protocol storage. And the middle, yes, is the system platform. Yes, this is how the interconnects. It says virtualization, nexus, is managed with resource manager. Yeah? And the top, yes, okay. Then the tutorial resource manager. And at the top, there is a viewer, there is this server, this is high, this control, this is recenter. We need visual zones for security reasons, yes, because we have a many customers, yeah, so we have the system, then we need to secure, yes. And the management of whole system uses visual zones. Yes. Okay. This is a cloud connectivity for, yes, you can see, yeah, these cables, yes, this fiber channel, network and Ethernet connected to system nexus. System nexus switch is connected with public interconnect switch, yes, with VPCs. Port aggregation, yes, and 2 gigabit with the HCLA from each of its cables at 10 gigabit speed, yes, from the lane chassis. Okay, and when the system boot up, yes, then show you the management. For this, it is client management. When you buy the servers, like you buy virtual machines, then you have this management. This is the cloud management. Yeah, you see your virtual machines. You can create a new virtual machine. So you can create the networks, internal networks. Yes. You can do the management of your virtual infrastructure. Yes? Okay. Maybe you have a question about this infrastructure. Are you waiting up? Okay. Maybe you have a question. What is this called? What was that? Directly to the public, yes? Okay. can connect network servers to the hardware, yes. But it was, in some reason, actually in reason of the Ethernet connectivity, the public Ethernet connect doesn't connect to the internet. They can do the port aggregation. Yes, we can do the lot port aggregation, and we have more cables. Yes, we need connect for availability and load balance. And if we have the biggest infrastructure, have more great capacity, yes, then this port we need for connecting to very fast. Yes. And here we can connect anything else. Yes. Okay.
Everything what the server's configuration and network configuration do with this unified infrastructure management. Yes, we can configure the LAN. Yes, configure VLANs here. Yes, configure storage network, configure virtual storage network. Yes. And configure the service profile. And service profile, it is a description of our service. Yes, it's like XML file. We have a description of our configuration. We have the MAC addresses in there and network connectivity, yes. And then we associate the service profile with the physical blade. Okay. Okay. say is Blazor. Okay. Now in our operations is we do boot from sun, yes, and terminal virtual machines like cloud director, yes, boot from VMware data store is connected to NFS. Okay, maybe some questions. Okay. Okay, like loop, yes. Scale, yes. No, it's possible, yes, by design. You need to connect all the chassis to the public internet switch, yes. Because there's from this product standard model you can see here. From this public standard model. Okay. Let's see. Okay, E6 is up and running. I'll check the other systems. Okay. Okay, now in short time automatically start booting the virtual machines as a part of the cloud. Yes, it's the VMware. Are there other questions? This is domain controller. It's meant for authentication, for user authentication. Now we're waiting for boot up the virtual center and vCloud direct virtual machine. Yes. Like this? Actually, maybe because now it's a good process. Yes. Okay. Now we can connect the network. So we can sign the email research. I'll show you the component. domain controller, virtual center, VMware, and vCloud array. Yes. And issue manager who's responsible for security. Yes, who build the network. Yes. Okay. This is the administration profile for VMware hardware. Here we have organization. And in this organization we have this application. Yeah. Okay. This is VMware Cloud Director Management, and actually this is a customer self-service portal, yes, where they can create their virtual application. Any question about that? Okay.
So today you made one record of building a tower. There is no
I don't know, maybe.
We have evidence.
Yes.
So you can make a like a Guinness World Record.
Yes, like some record. Okay, maybe, I don't know. But yeah, we can. How much time? 25 minutes, yes. Okay, but this is actually because of this design of infrastructure, yes. Because we have because we have this easy connectivity of systems, yes. Okay. Do you have any questions? Okay. Then I would like to say thank you for Tommy and for IPRO guys. Okay, I'll thank for your time. Okay, bye.